Hey guys, how you doing? It's Coach Scott here, and yeah, we're getting ready to go into our third video in this series. We're going to be talking about ionic bonding. We'll be spending about the next 3 or 4 weeks talking about bonding, and I think it'll be sort of cool. All right, so let's see if we can get this advanced, and there we go. So we're going to be studying three basic types of chemical bonds. The first one is the ionic bond, and where that bond comes from. And if you think of what is a bond, it's a gathering together. It's the electrostatic attraction between ions. The second one, and we're going to be studying that in about 2 or 3 weeks, is the covalent bond. And that is the shearing of electrons between the atoms. Okay? Then a metallic bond, all right, each of those atoms, they'll bond to another metal atom with a sea of electrons. There's a lot of electrons in metals, and they'll cover it. And we'll cover this in a later unit, of course. All right, so we studied electronegativity in Unit 3. And electronegativity, definition is how strong that atom is going to attract electrons. If an atom has a high electronegativity, then they're going to be able to attract electrons away from atoms with a lower electronegativity. And of course, this is all based on Coulomb's law. So what happens? When the electron is removed, all right, and it can occur when there is a difference of electronegativity that's 1.7 or higher between the two atoms. Now, once these positive and negative ions are formed, they become attracted to each other via the electrostatic force, the Coulombic force, F equal K, Q1, Q2 over R squared. So what happens is you have that positive cation, you have the negative anion, and they'll just come close enough together to where there's a bond formed. All right? And this happens, well, almost between a metal and a non-metal. Now, some of the heavier non-metals, they're in the group 5, group 4, things like indium, titanium, tin, lead. They can act like a metal even though they're in the P block. Okay, so this is how this works. You got a neutral atom, and it's got a valence of 1. It's got one outer electron, and it comes near a halogen, say, that has 7 valence electrons. Now that neutral atom has very low electronegativity with the 1 valence, the metal. The halogen with the 7 valence electrons has a very high negativity. So when it gets close to each other, that electron is pulled away by the nonmetal. All right, and that gives a negatively charged ion. And when it pulls that electron away from the cation, that's a positively charged cation. Then they'll come together and form that electrostatic bond. So, the atoms with the high electronegativity are going to attract valence electrons from the atoms with the low electronegativity. So when they become close together, that electrostatic will bring them together and you have that bond. Now let's think. Which elements are going to have low electronegatives and which are going to have high electronegativities? Well, we studied that in Unit 3. Of course, the nonmetals up near fluorine, they have a very high electronegativity. The metals, much lower electronegativity. So, we call these compounds with a cation and an anion an ionic compound. Why? Because they're composed of ions. Even though the ions are charged, those compounds are neutral. They're electrically neutral. They balance each other out. And the forces that are held together in ionic compounds are called what? Ionic bonds. So what happens with sodium chloride? When sodium and chlorine are close to each other, or you burn chloride gas, or you put those together, a violent reaction occurs where that chlorine with that high electronegativity steals that electron, all right, forming that sodium cation and the chloride ion. Let's see if we can't get this to play, and I'll pause for a minute and then bring it back right on over there. Well, we'll see it tomorrow during class. So, there's a table of the electronegativities, all right? And you can see those that got like a below a 1, very not electronegative. The ones where they're very high, up there. And if you notice, the only way we can have a electronegativity difference of 1.7 is when a nonmetal will react with a metal. It's the only way. So let's do a check. Which pair of electrons will form an ionic bond? Think about one. Which one are metals and nonmetals? I'll give you a sec to think about it. And of course, that would be B, potassium, which is in group 1, and bromine, which is a halogen, group 17. Which pair of electrons will form an ionic bond? Think about it. Which has got a metal and a nonmetal? Pause. And of course, you see sodium and chlorine, otherwise known as salt. Will an ionic bond form between scandium and fluorine? True or false? Well, scandium's a metal, so of course that is true. Fluorine is, of course, a very electronegative nonmetal. Which of these compounds would you expect to be ionic? Now again, we're looking for a metal and a nonmetal. Pause. And of course, you guys chose C, strontium and chloride. Now, let's talk real quick about the properties of ionic compounds. And we see these things every day. All right. Now, ionic compounds are going to be crystalline solids at room temperature. What do we mean by crystalline solids? What we mean by that is that they have a structure, a geometric cubic tetrahedral structure. All right, because of this and because of the strength of that bond, they're going to have very high melting points, extremely high, like thousands of degrees. So we'll also notice that ionic compounds will conduct electricity when you melt them at very high temperatures, or you're able to dissolve them in water when they're aqueous, right? So we'll probably have a little activity of that today when we explore that. So those are some examples, what we see right there. There's sodium chloride. You can see that's cubic. There's cesium chloride, all right? And that's cubic, but that's cubic centered, all right? Then rutile TiO2. TiO2 is what makes paint white. All right. Now, new definition for you. Formula unit. A formula unit, all right, tells us what the lowest whole number ratio is of cations and anions in an ionic compound. You're not going to find a sodium atom or ion and a chloride ion just there together. They're not. There's clusters of those in a known geometry, okay? And what a chemical formula does is it shows us the kinds and numbers of atoms, and a formula unit is the smallest representative unit of that substance. And every one of those ionic compounds is not planar. It's got a 3D surface of those positive and negative ions in a set whole number ratio. Okay, guys, that's our introduction to ionic bonding, and we'll cover it tomorrow, and we'll cover how to predict whether something's ionic or not in our next little lecture. So this is Coach Scott saying have a good evening, and peace out. Bye.